Good afternoon, class. I hope you are all doing well. That's fantastic. In our previous studies, we discussed about density and how to find density of an object. So before we come to today's lesson, I want us to recap on what we did the other time. So now, when we say density, what does it mean? And then what is the formula for finding density? Class? Very good. So when we say density, density is defined as the mass per unit volume of an object or substance. So per the definition here, we were able to come out with a formula for finding density. So I'm going to write the formula on the board for us to see it. So what is the formula for finding density? Density is equal to mass over volume. So it means that density is equal to what? Mass over volume. So I'm going to use the symbols alone. What is the symbol for density, class? It's rho. And then mass, small m. And then volume, V. Very good. So this is the formula for finding density by using the symbols alone. So from here, we move straight to the business or topic for today. Determination of density of an irregular object, for example, stone. So this afternoon, we are going to determine density of an irregular object, that is the stone. So before we conduct this experiment, I have with me here some of the materials or apparatus needed. So the first one here is the measuring cylinder containing a known volume of water. The second one here is the stone, the irregular object. And the last one here is the electronic balance. I also have with me here calculator for calculations. Very good. So now, per the formula here, mass over volume. So we need to find mass of the stone and then volume of the stone. So quickly, I'm going to place the stone on the electronic balance to find the mass of it. So gently, I place it on it. So let's look at the readings over here. Our mass is 10.86 grams. 10.86 grams. 10.86 grams. That is the mass of the stone. It's left with the volume of the stone. So how do we find the volume of the stone? The first thing is we look at the initial volume of water in the measuring cylinder. So let's look at it, class. So the volume here is 60 centimeters cube. That is the initial volume of water. Initial volume of water. That is V1. It stands for volume 1. It's what 60 centimeters cube. That is our initial volume. From here, we have to get the final volume. So I'm going to gently immerse the stone. So I have tied the stone with a thread. So I'm going to gently immerse the stone into the measuring cylinder containing a known volume of water. So I'm immersing it gently, slowly into the measuring cylinder. Very good. So class, let's look at the water level now. So the water level has risen, it has moved up. It's on the 63 centimeters cube mark. That is the final volume of water. That is V2, which means volume 2. 63 centimeters cube. Fantastic. So right now we know our V1, that is the initial volume of water, and then V2, the final volume of water. So how do we get the volume of the stone alone? It's very simple. It's just by what? Deducting the initial volume, the V1, from the final volume. Very good. So now, to get the final volume, or the volume of the stone alone, so volume of stone alone, it is equal to what? So how do we find the volume of stone alone? We just subtract volume 1 from volume 2. initial from final. So V2 minus V1. So what is the volume for V2 class? It's 63 centimeters cube. Minus V1 is what? 60 centimeters cube. So what do we get here? Class, 60 from 63, what do we get? We get 3 centimeters cube. Fantastic. So right now, we know our volume of stone and then mass of stone. Therefore, we can find the density of the stone easy. So from here, we go to the main formula again. Density is equal to mass. So what is the volume for mass? 10.86 grams divided by the volume here, 3 centimeters cube. Very simple. So I have with me here a calculator. I'm going to calculate it. So 10.86 divided by 3. So what do we get? Our answer here is 3.62. Density is equal to 3.62. From here, we attach the unit to the new density that we have here. Grams over centimeters cube. So it will be what, class? Grams per centimeters cube. So now this is our density of the irregular object, the stone. Thank you.